Hello, my name is Nicole Tiburcio, and I am doing a presentation on old image artifact restoration for the course Applications of AI COSC 645 at Maryville University. This is going to be our agenda of what we'll be outlining today, shown here, and then we'll finish with the code sample. And then we will be reviving memories using generative face completion with patch-based generative adversary networks for old photo restoration. The algorithm uses advanced deep learning techniques to analyze and understand facial features, textures, and structures in the input image. By applying patterns and features learned from a pre-trained generative adversarial network, it produces a regenerative or rejuvenated version of the face, significantly improving the quality, sharpness, and authenticity, resulting in a more visually appealing and realistic outcome. More lifelike, we should say. And we would do this by using Google Colab with the Python programming language. For us personally, we're going to be using this application for restoring family and photo, restoring old-time photos of our friends and our family. However, there's limitless possibilities of how to use this application elsewhere, including, for example, cultural heritage and preservation, like in museums, consumer and personal use, like I've already mentioned, entertainment and media, like old films, academic and research, and then healthcare for old medical images, forensic technology, and also law enforcement for old investigations, and publishing and media production, like books and magazines, newspapers, documentaries, and educational videos. Our envision use is similar to our application use, and we also would like to see cultural heritage preservation to bring back old photos and documents and artworks to current realistic reality of what those images would look like back in the day. We had scoped out different applications that are very similar to our current application, but these other applications use more for the background and the whole image itself, where ours just focuses on the face and the improvement of the face. Such as ESRGAN and SRGAN for overall quality improvement of the photo, pulse likewise, and then deblur is for GAN is for removing blurriness of images, and deoldify is for color enhancement. So similar but different. And then we have real world examples where you can go on these different websites and sign up and pay a small fee, whether it be monthly or annually, to put your images on there and have them be restored, and they all do similar image restoration. We believe that our application is new and novel because it offers a unique capability to seamlessly blend traditional restoration techniques with advanced generative models. This allows it to reconstruct facial features with a level of detail and accuracy previously unattainable, enabling not just the restoration but also the resurrection of the historical figures and appearances from severely degraded or incomplete images, such as if an old photo part of it got ripped off, or if there's old lines on the photo, which we tend to see a lot. This can profoundly alter our connection to and understanding of history once we use this application and restore the photo. The planning and development of this model, we first want to clone the repository from GitHub, and then next step will be setting up our environment and pip installing some libraries like Basic SR, Face XLib, Real, ESRGAN, and some other ones not mentioned here. And then we will also enable the GPU if necessary. Step number 3, we download and pre-train the model. We integrate pre-trained models for high quality restoration. Step 4, we compile the CUDA extensions to be able to handle our computational demands required in image restoration. Step 5, we prepare input images for image processing. Step 6, we implement core functionality to load and process the images and then apply the GFP-GAN model to restore photos. Step number 7, we execute inference script, restore faces in input images, and adjust parameters for different image sizes or scaling. Last, step number 8, we will visualize and evaluate using CV2 and Matplotlib to read and visualize restored images. We had mentioned some of the libraries that we use. The framework that we're using is going to be PyTorch for building and running the models, and we use Python programming language. And then some other supporting libraries will be the OpenCV and Pillow for image processing, and then Matplotlib and CV2 for data visualization of those images, and some of the other ones we might know like NumPy, ScikPy, and Scikit-Image. We continue building our model using Ninja to streamline the process, file input model for configuration adjustments, and then the setup cloning like we've mentioned from the GitHub of the repository. And then we mentioned a few other things like installing via pip the dependencies that we need to use and making file revisions for compatibility. And then we also need computation resources such as Google Colab that you had to use instead of Jupyter because of the expense that we have due to image processing. And then also using GPU if necessary there. Training data, we have used high resolution and low resolution image pairs that focuses on facial images purposely. And then there was some that we used that also show the whole body, but we'll get to that later. And then public available data sets we had to use. We were hoping that they would be diverse in their collection of showing various ages and genders and ethnicities. And then we would have to also process the images by aligning and cropping and augmenting those images. And then training the framework using PyTorch. And then validation and testing metrics PSSNR and SSIM, which is used specifically with GFP-GAN. And both of them measure the quality of the restored images by comparing the pixels of the restored image to the original high-resolution image. And both of these use higher values, indicate better quality. So we want higher values for both of them. We want to use the pre-trained model. Right here you'll see GFP-GAN V1 pathway. And then the training process, we use the convolutional neural networks and the generative adversarial network to optimize restoration from low resolution to high resolution images. And then the loss function comparison restored output to original high resolution images. And here's the training data that we had briefly mentioned already to set up your environments, train the model, upload the images that we want to restore, execute the image restoration, run the GFP-GAN algorithm on those selected images that we uploaded, and then we will want to view those results. And then if we like those results, we can obviously save them to our computer. And then we will probably most likely face some roadblocks with our program as well. And some of those anticipated roadblocks would be not having the best quality of images and not being diverse like we expected, with having ages from 0 to 100 or ethnicities from, you know, different backgrounds and facial expressions. Next one would be not having enough computational resources, and then also not having model optimization to where we would like with high accuracy scores and efficiency, and then not being able to use highly damaged photos and being able to restore them. Another roadblock would be avoiding unrealistic features in restored images and carefully tuning and validation accuracy as needed. Once you implement this application, some of the roadblocks might be just not being friendly enough for the user, or not being able to scale at mass production as you like because of potential cloud issues. Our cloud might not be large enough to hold that many users at one time, and it might slow down the system. And then also having to always update through the system of depreciated software systems and libraries. And then also having to see sometimes code conflict due to depreciated libraries or the systems coding differently, which we did see here. And then once we launch this, we really want to advertise for our program. And if to the people that want their photo restored or their family photos restored, the thing is that we want to make sure that it's in swift and easy user adoption once we market this. And if not, then a lot of our money will be lost, or we'll have to have some kind of comeback or just advertise more. And then once again, we always will have ethical concerns that will be brought up into any application that we use. We want to prevent the misuse of restored photos or anybody trying to pull a deep fake on this. Privacy concerns for the people that do have the photo enhancement, make sure that they approve for their photo to be, or consented for their photo to be done. And then also having non-biased results in our training data. And then any copyright or intellectual property rights that can be violated. And the journey just begins there with this application, because it is an image and we don't want to defame or defraud anybody. And we will go on to round 2 here to show you the code.